Hey, welcome to Analog Output. I've been doing these synth DIY videos for a little over 3 years now, and the very first videos I did were documenting the building of a ribbon controller, which I have here. It's a stick of wood with a soft pot membrane potentiometer on here, 500 millimeters long, can't fit it all in shot. Connects via a cable to an interface box, which breaks out two control voltages and a gate output using an Arduino based interface board inside there. And I was pretty happy with the results of that. And then sometime in the intervening time, and this might have been like a year and a half ago or something like that, I don't remember exactly, I discovered it seemed not to be working. It appeared that the soft pot was damaged. Not damaged in any visible way, but it just did not seem to be working correctly. Came back to it a while later thinking, okay, it's probably time to do something about this. But before going ahead and ordering another soft pot, I took another look at it, and the soft pot was behaving just fine. So I don't know what that problem was. I thought, okay, well, I can just shove all this back together again and be good to go. But I was a little unenthusiastic about doing that because it was the first electronics project I had built in several years. I built it on a proto board. It was not the finest example of electronics construction, and there was also the software. I always was not too happy about that software. It always seemed like it was way more complicated than it needed to be. In any case, it always seemed to me as though the code was kind of more complicated than it needed to be, less well organized than I thought it could be, and I always had a little trouble, figuring out what was going on with it and so forth. And I kind of felt like, between the quality of my hardware and the quality of this software, I think it would be a good idea to rebuild the interface for the ribbon controller and reprogram it. So I boldly forged ahead and shoved everything back into storage for another year or something like that. And it's time. For the hardware, rather than a proto board, I'm using a printed circuit board. Some time ago I made a video about this board here, Dacino. This is a rather general purpose circuit board for interfacing an Arduino Nano with control voltage and gate inputs and outputs. It's intended for use as a basis for synthesizer modules. It's the basis for the dual quantizer module that I showed you a while ago. There's also a smaller version of the Dacino board, this one here. This one is set up not for use in a synthesizer. This is set up for using battery power to be used in things like interfaces for controllers, purposes like this. So it has a footprint for an Arduino here, Arduino Nano, and it's got a footprint for MCP 4922. Did I get that number right? I think so. Digital to analog converter. It's also a footprint for an op-amp, which later on I realized was kind of superfluous because it was just buffering the output, and then I realized the DAC output already is buffered, so it's got everything you need for this interface. So I thought I would use that. One thing I didn't like about the old interface is that it was USB powered, which has a couple of disadvantages. One is it means that you need to plug it into something. You need to have a USB hub or a phone charger kind of thing or something like that to plug it into, which I don't always have immediately available. Another thing is that the voltage you get on the 5-volt pin of the Arduino with it plugged into USB is maybe somewhere around 4.5 volts or something like that. It's not a very good 5-volt reference, which for this purpose is not that big a deal, but it would be nice to have it at least a little closer to actual 5 volts. So on the whole, I decided I would rather have this thing powered by a 9-volt battery. Put a switch in, so you can turn it on and off, and then one less cable to worry about, one less thing to have to plug in. For the enclosure, this was the old enclosure. I was thinking I was going to reuse this box, but it's pretty tight with a 9-volt battery shoved in, and I ended up deciding a slightly larger version of the box would be a better thing. So I also just decided rather than having the jacks installed on the lid of the box, it would make more sense to have them installed on the other side of the box so that you can just take the lid off cleanly to change the battery without having to have the lid connected to stuff inside the box. So that's what I've got going on with this thing here. You've got an unsullied lid here and a slightly sullied bottom part here, which I need to drill out these holes and get them set up for assembly. So here is the circuit board. This circuit board is soldered up. I've got the battery holder connected to it with a switch. I've got the input jack here. I haven't attached the output jacks yet because I've just been testing this, putting a voltmeter on it to see if it's putting out the right voltages. But that's sort of the next step, is connect those things there using some nice flexible silicone insulated wire here. As for the software, let's take a look at it. Here is the software. It is a lot shorter and simpler than the old software. It starts off with a bunch of definitions, and then there's a 3-line setup routine that just initializes the DACino library and writes a false value to the gate output channel, so it's starting with the gate turned off, and it enables the pull-up resistor on the potentiometer input pin, and then in the loop it just reads the potentiometer. If the value is above a threshold, it means that the soft pot is not being touched, and so we set the gate to false and set the number of entries to 0, the number of entries in the array, which we write into, and in the other case, when we're below the threshold, we take the pot value, we write it into an array, and once we have enough entries, we compute a running average of the entries in that array and convert that into a number that's proportional to the finger position along the strip and call that the CV output value. We write that CV output to both channels of the DAC. We write the gate value to the digital output for the gate. We delay a millisecond and we just keep doing that. That's all there is to it. Pretty simple, pretty straightforward. Okay, it is now about a month later. I put all that together and did some troubleshooting, and things came out fine, except that I discovered that the output jacks that I was using were really crappy. So I ordered some new ones. I got some new ones. I put them in. I think we're basically done. Here's the box. See the board in there somewhere. Maybe if I took the battery out, you can see the board. You can see the jacks down here. There's a power switch. There's a power LED. Just got to close this up and we should be done. There you go. It's working. Check out the links in the description. Like, subscribe, you know the drill. Tune in next time. See you again on Analog Output.